Okay, today let's start with trigonometric functions and their graphs. Yes, as you know, the simple trigonometric function is assume that this is fx equals to sine x, or fx equals is tangent x, or you don't see in general, but you can also see as cotangent x. Okay, so let me show you some graphs of that functions. For instance, if it is the sine x, assume that the function is sine x. Before starting, you'd better draw a graph by using x and sine x, for instance. Let x is 0 degree. So x is 0 degree. That time, as you remember, sine x is 0. And assume that right now the degree. That time the value of sine is 1. And we know that if the x, you can also see it is 180 degree. Again, it is 0 plus pi over 2. Again, it is minus 1. And finally, another pi over 2, so it is 2 pi, as you know. Okay. If you see such, you can draw your line easily. Right now, start with 0 degree, then pi over 10 here, and 3 pi over 2 here is the, yes, as you can realize, this graph is sine x, okay? This is the one period of sine x, and same as sine, for instance. Okay, assume that right now this is cosine. By using the same graph methods, x, and look at the x and cosine x value. Okay, let's start with 0 degree. If the degree is 0, if the x is 0, as you know, the value of cosine is 1. For pi over 2, it is 0. For pi, it is minus 1. And finally, for 3 pi over 2, it is 0 again. And finally, to complete one period, you can say it is 1. And as you can realize, it starts with 1 here, and then 0 for pi over 2, and then minus 1 for pi. And then, yes, 3 pi over 2, still it is 0. And finally, as you can see, this is one period for cosine value. Okay, this is the one period for cosine value. Okay, so this is the graph of function sine x, and this is the function, this is the graph of function cosine x. Okay, so yes, to be honest, in general, you are going to see them in different forms. For instance, let me show you once again. Assume that fx is cosine x plus 1. As you can easily realize, this function right now is the transformed or translated function of cosine x. In other words, as you remember yesterday, I explained, our main function assumed that gx is cosine x, okay? But when you look at the function fx, you multiply with gx. Fx is multiplied with 2 gx and plus 1. Okay, actually function fx equals to 2 times gx plus 1. As you can easily realize, plus 1 means that translation upward 1 unit. What about 2 2 here shows us the magnitude of the amplitude. Okay, here this 2 shows us the amplitude of the function. Let me show you what these terms are. What the meaning of these terms. Okay, once again, I draw an sine function here. Yes, the maximum and minimum values here, as you can see, for the simple sine x value, the maximum point is 1 and the minimum point is -1. Yes, right now amplitude is 1 for that function. What about for the new function? That time these coefficient 2 as a multiplication gives us the new amplitude of the function. Right now, yes, this is sine x. Okay, this is sine x, or let me show you cosine x. Yeah, right now this is cosine x. Okay, this is cosine x. Here is +1 maximum point, and here is minimum point. Okay, so and this is the cosine function. Right now, let me show you the that translation. Okay, here we can say that this line y equals 0 is the axis of symmetry for the function, and you can easily realize that the axis of symmetry is go up 1 unit, and right now axis of symmetry is here for that new function. Okay, right now axis of symmetry is here, and the amplitude is 2. Amplitude say that from axis of symmetry 2 units up is the maximum point, and it is 3, and 2 points down it is -1 minimum point. So let me show you the final graph. Yes, as you can easily realize, this is our final graph right now, and at point 1 on the y-axis, and our new amplitude is 2. So as you can easily realize, the main cosine function is translated by using this method easily. Okay, so let me show you some basic translations here. Okay, as an example, yes, right now fx is 3x and +1. Okay, right now, as you can easily realize, in front of x you see coefficient 3. Okay, as a multiplication, you see 3. That time, yes, we know that this is the amplitude, and we know that this is the translation magnitude, translation value on the x and y coordinate plane. But here coefficient 3 is about 2 periods. What I mean here, as you can realize, a sine value, the value of an sine function is between 1 and -1. Okay, 1 and -1. In other words, maximum point 1 and minimum point -1 for an sine x function. But at the same time, you're going to see that if you draw the line once, if you draw the function once again, you are going to see that for a simple sine x or cosine x, you see a periodic behavior. What I mean, for each 2 pi degree, you see the same periodic behavior. Okay, so for 2 pi it is same, for 4 pi, for each 2 pi, for each additional 2 pi, we are going to see the same value. For instance, you can say that sine x plus 2 key pi is always sine x at the same time. But be careful, key is the positive integer always. For instance, key is 1, 2, 3, blah 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 blah, something like this. Okay. So if you say that the key value is always positive integer, that time you are going to see the same periodic behavior for that graphs. So as you can realize, the coefficient tree affect the period. In other words, if you see that sine a times x plus b is the function y, that time your new period is 2 pi over a. No matter it is sine or cosine, it is same for cosine at the same time. Ax plus b is y. So yes, still the periods. We also show the period with t. T represent the periods, and t is 2 pi over a. Okay. So as you can easily realize, the period for that function is period for that function. Let me write it with another color. Period, or t, is here 2 pi over 3. Okay. So yes, right now let me show you this new function. Yes, let me show you a new function. And also I need to explain you the amplitude. Amplitude is 2 here, and the translation is 1 unit up for axis of symmetry. Okay. Yes, by using these details, right now you can easily draw the line. Okay. Let's start from 0 once again. And draw your one period. But that time, as you can realize, if it were 2 times sine x plus 1, these periods would be 2 pi. Okay. But right now it is not only x, it is 3x. Okay. So it is 3 pi over 3. Okay, one period is start from 0, and one period finish with 2 pi over 3. Okay, so yes, your amplitude is here. Too. And be careful. Still, we have 1 unit up. That's why I'm going to move it. 1 unit up. So our final is like this. Okay, let me draw firstly 1 on the y-axis, and yes, we see that amplitude is 3. It is 3 here and minus 1 here. So yes, let's yes, yes, it is a sine function. So start with here this, and be careful. Period is not 2 pi. Period is 2 pi over 3. Okay. So draw another period. That time this is the k. In other words, 4 pi over 3. Let's go on again. Right now, this is over 3. In other words, 8 times pi over 3. Okay, you can also go on like this. Okay.
No.
Is there any question? Okay, so for that subject, for that lesson, you can see sometimes that kind of questions. Let me show you. Okay. Yes. Yes. Assume that this is our graph. And the shape of the graph is like this. This is minus pi, and this is minus 2 pi. Yes, it starts with like this, and then like this, and then like that. Okay. The maximum point for the amplitude is 3, and minus point for the amplitude is minus 3. Okay, this is minus 3. And here is 2 pi, here is 2 pi, and here is 4 pi. Can you please explain me the equation of that graph? Can you please explain me the equation of that graph? Okay. By looking at that graph, please try to find the equation of that graph.
Three sine x.
3 sine x?
Yeah, I think.
Are you sure? As far as I see, you say that y is 3 sine x. Are you sure?
No.
Okay, let's check the period once again. Okay, let's try once again. Is there any other answer for this question? Okay, be careful. Yes, you are right. Amplitude is 3. I agree with you. Amplitude is 3. Let's look at this question once again. We see that, to be honest, firstly, you need to look at the origin, okay? As you can realize, graphs start from origin and maximum point is 3, and minimum point is 3. It means that amplitude is 3. Okay, no problem. And by looking at the shape of the one period, when you look at the shape of the one period, you can easily say that this is the function of sine x. Okay, no problem. So in general, you can say that it is 3 times sine x. But be careful. One period is here 4 pi. So you know that if the sine a times x plus b is our function, that time a is about the period. In other words, We know that period is 2 pi over a. So right now, to find the value a, 2 pi over a is 4 pi. In other words, a is here for our function 2 pi over 4 pi. In other words, 1 over 2. So you can easily realize that actually our function is 3 times sine x over 2. Okay, so this is our real equation. Okay, can everybody understand it?
Yes, sir.
Okay, good. So yes, let me show you some more questions. Let me show you some more questions. Just a second. I'm checking I'm checking my books to show you more questions. Just a second. I'm gonna come back. Okay. I'm going to show you different kind of questions, and they are harder than that question. So let's check these questions together. Just a second. Yes. Okay. Let's look at this graph and tell me its equation. Okay. This is 3. This is 3. And start with 3. And here is 8 pi. And here is 6 pi. And here is 4 pi. And here is 2 pi. Okay. So, yes, this is minus 3. So, please tell me its equation. I'm asking the equation of that graph. Okay. Okay, please tell me the equation. Okay, I'm waiting for your answer. Okay, is there any answer?
Y is equal to 3 cos 1 by 8x.
Okay, y is 3 times sine x or cosine x?
Cosine.
Okay, cosine x.
Cosine 1 by 8 x. Like
Cosine 1 over x. 1 over 4.
1 over 8.
Sorry?
1 over 8.
Yes. No. Be careful. You see that one period is here, 8 pi. So let's look at it once again. A 2 pi over A is 8 pi here. So A is here, 2 pi over 8 pi. In other words, 1 over 4. That's why this is our final equation. Okay. Okay, good. So I'm going to show you different kinds of questions, harder than that questions. You can also check them. So let me show you some questions once again, especially translations of periodic functions. Translating that periodic functions is the most important part of that math subject. Because as far as I remember, hardest question you can see comes from that subject. So, yes, let me show you another type of questions. For instance, I can say that right now. In addition to amplitude and periods, I can say that let's put angle of sine. Okay, so in general we can say that times sine or cosine, no problem. It's x plus b and sine sine. If you this is the general form for an trigonometric function in terms of sine x or cosine x. Represent the amplitude. Okay. C represent the period is 2 pi over c, and translation on y is the translation on. For instance, let me show you by using this. But I'd better explain you a more simple question. Okay, assume that the function f(x) is pi over 3, pi over 6, okay? Okay, if you see such an extra in degree or radian, no problem. You need to understand that. To add extra value means that we know that actually sine x starts from 0, okay? But if you see such an extra angle value, additionally, your function goes through left by that value. What I mean, for one period, we know that starting point is 0, but this is for sine x, but let me show you the new graph right now. The starting point is minus pi over 6. So our new graph is like this, okay? And as you can easily realize, this is not 2 pi, this is 2 pi minus pi over 6, okay? Still, no problem, still the period is 2 pi, but right now, starting point goes through left, because we add extra value to our angle. Let me show you other option. let me show you other option. Okay, that time I better erase it. Let me show you the other option. Okay, that time assume that our function is sine x minus pi over 6. Okay, that time our new function